Welcome to the celebrated High Achievers Mentorship Program, CHAMP. We are bringing academic dreams to reality. So, in this video, we'll be talking about friction. Yes, so what's friction? Friction is a force that tends to oppose motion. Tends to oppose motion. So, let's say we have an horizontal surface like this, then we have a body resting on this surface. So yes, this will be your what? Let's say this body is of let's say 10 kilogram, or yes, 10 kilogram. Let's say the force is trying to push this body in this direction. If the force is pushing this body in this direction, the frictional force will be acting antagonistically to this force. So if the force is going in this direction, the frictional force will be going in this direction. If the force is going in this direction, if the force is going in this direction, the frictional force will be doing what will be going in this direction. So the frictional force is always opposite to the force, and is always opposite to, F is equals to ma. So if the body is moving, is accelerating towards the direction, the frictional force will be doing what? Will be acting towards this direction. So please master that. Yes, and let me just talk on the forces. So that we understand this topic well, I want to take my time to get you to explain how to resolve forces, because this is really, really vital. So yes, let me stay on horizontal surfaces. Horizontal surface. Now, this is it. Let's say we have a body of mass 15 kilogram. Yes, and they say this body is pushed by a force. Now, the first thing you need to note is that your weight will always act what? Your weight will act downwards. Your weight is always acting downwards. And what's the formula for your weight? Weight is equals to mg. Weight is equals to mg. So the weight of this body now is what? 15 times 10. That's what? 150 Newton. 150 Newton. Yes. So let's say there is a force that acts vertically too. It's acting upwards. That's your what? R. This is your what? Your reaction. Your reaction. Yes. So the vertical forces that we have, is always what? Is R and what? And W. R and W. And under in an horizontal plane like this, your R is always equals to your what? Your W. So R is equals to W. R is equals to what? Mg. So please take note for what? For horizontal plane surfaces only. For horizontal surfaces, please take note of that. Not every case. We will check it out. Yes, when we start inclined plane. Yes. So let's move on now. Let's take another case. So yes, let's check for the horizontal. We've checked the vertical forces. We said we have R and what? We have R and W. So let's check for the vertical forces. Let me just use the next page. Yes. So let's say we are treating a body of mass 15 kilogram. We said the weight is what? 150 Newton. Then we have what? A normal reaction. Yes. So we used to have a force here. Like there's always a force. This is just the vertical force. Let's check the horizontal forces too. The horizontal forces. Now let's say we have a body pushing it in this direction. F pushing it in this direction. What will be the direction of your friction at this other side, the left? This is the frictional force. Yes, what if they now ask what will be the acceleration? What will be the acceleration? The acceleration will be gotten from, first of all, get your what? Your net force. If a body is pushing it in this direction, there's a force pushing it in this direction. There's another force hindering it in this direction. So your net force is what? Your net force is what? F minus FR. So if the force that is used to push it is 10 Newton, if you are using 10 Newton to push it in this direction, and your frictional force is 3 Newton, the force that will produce your acceleration will be what? 10 minus 3. Do you understand now? So that's just that. So let's say, so this is it. The force that is pushing it, F, minus what's your frictional force? Just write it. Is what to give you what? Your net force. And F minus FR will give you your what? Your acceleration. What's formula for F? Ma. So from here you can get your acceleration. So please take note of that. Let me just take another case now. Yes. And please note, if this body is not moving, yes, I hope you must have heard. Yes. So yes, let me just talk on this before we move on to the next case. Yes, what you need to know is that now, if this body is not moving, if this body is not moving, your acceleration is what? Your acceleration is 0. Yes, if this body is not moving, please take note. If this body is not moving, your acceleration is what? Zero. Your acceleration is zero. And you must have known that they used to say mu is equals to tan theta. This formula is only functional when there is movement, when there is motion. Yes, if it's not moving, like when we get to sliding bodies now, if that body is not sliding yet, your mu is not equals to what? Tan theta, because this is where students do have problem. Mu is equals to tan theta when your body is moving. Please take note of that. Yes, let's take some questions on these cases now. It's actually divided into three. So we have horizontal forces, then we have horizontal forces plus, then we have inclined plane, then we check dragging bodies, and that will be all for friction. So let's take our first question now. So I'm sure you know how to resolve forces now. We have the first question. A wooden block of mass 1.6 kilogram rests on a rough horizontal surface. If the limiting frictional force between the block and the surface is 8 Newton. Calculate the coefficient of friction. So let's do this together now. He said there's a wooden block. This is a wooden block of mass 1.6 kilogram. So it's resting on a rough horizontal surface. If the limiting frictional force between the block and the surface is 8 Newton. Yes, so this is it. The block is of mass 1.6 kilogram. What will be your weight? I told you that your weight is what? Mg. So your weight is equals to, what's the mass? 1.6. What's G? 10. That's what? 16 Newton. Yes, they said if the limiting frictional force between the block and the surface is 8 Newton, so your frictional force is what? 8 Newton. 8 Newton. Oh, I forgot to give you the formula for frictional force. Frictional force is generally equals to mu r. Please never forget this. Frictional force is what? Mu r. Mu r. Yes, where your mu is the what? Coefficient of static friction. So we have to find our what? Our mu. Let me just solve it here. So what's our formula? Frictional force is equals to what? Mu r. Yes, so they've given us our frictional force to be 8 Newton. Then we are looking for our coefficient of static friction. Then what's our r? Yes, our r is here, right? This is our r. Then we established that for vertical surfaces, r is equals to what? W. R is equals to W. So your R is equals to what? 16 Newton. So mu times 16. So 8 is equals to 16 mu. So your mu is equals to what? 0.5. Please take note of it that this your R, this your particular R is only equals to W when it is what? When it's like this. Don't worry, we can take questions when it will not be equal. Yes, but for plain horizontal surface like this, your R is always equals to W. We got our 0.5. Yes, if you don't get it well, you can just play back the video and try to watch it again. Yes, next question now. Yes, so we have the next question. Calculate the magnitude of the force. So you are looking for your force required to move a 20 kilogram object. Yes, you can just give a sketch. This is it, a 20 kilogram object along a horizontal surface. So this is the force now, F. Please, it's very important to sketch diagrams for friction. It's very important to sketch diagrams. Yes, to move a 20 kilogram object along a horizontal surface, if the coefficient of friction is what? 0.2. So I told you that if the force is going in this direction, your frictional force will be in which direction? In this direction. So this is your frictional force. Do you get it now? And I told you that if the body is not moving, your acceleration is what? 0. They said to just move. So the body has not yet started moving. So your acceleration is 0. So what's the formula for your net force? As I gave you the other time, I said net force is what? F minus what? Frictional force. What's your net force? Net force is what? MA. F minus frictional force, right? What's your A? Acceleration is 0. M times 0 is equals to, you are looking for your F minus, what's the formula for friction? Frictional force is equals to mu r. right? So I can say minus mu r. I hope you are not confused up to this level. So what's m times 0? That's 0 is equals to f minus. What's your mu? They've given you in the question. The coefficient of friction is 0.2. 0.2 times. What's r? I told you that your r is equals to your what? Your weight. Your r is always equals to weight for cases like this. So r is equals to mg. What's your m? That's what? 20 times 10. So r is mg. So 0 is equals to f minus 0.2 times 20 times 10. That will give you what? 40. So f is equals to, I bring this one to this place. Let me just write it. 0 plus 40 to give you f. F is equals to what? 40 Newton. Yes. Do you get how I solved it? You can just play back to see if you understand the concept well. So yes, this is the next question now. A force of 20 Newton. Yes, let's just, I told you that diagram, that grammatic representation, a sketch is very important in friction. So yes, you have a block of, it's just sufficient to move a block of mass 4 kilogram. Please pardon my writing. This is the block 4 kilogram. So they said the force of 20 Newton applied parallel to the surface. Yes, this is it. We want to, this is the force. F is what? 20 Newton. Parallel. These two lines are parallel to the surface. Yes, but that's not yes, it's just sufficient. Okay, calculate the coefficient of friction. So you have to find mu. Yes, and you know that this is your weight. Your weight is what? Mg. So that's what? 4. Weight is mg. Weight is equals to what? 4 times 10. This is your g, 10. So what's your weight? 4 times 10, that's what? 40 Newton. And I told you that your reaction is acting upward. And for a question like this, your R is always equals to your weight. So R is what? 40 Newton. Do you get it now? So they said calculate the coefficient of friction. Now, if the force is acting in this direction, your friction will be acting in which direction? In this direction. So this is the direction of your friction. What's your net force? Net force is equals to F minus what? Minus frictional force. And I told you that this body is not moving yet. It's just sufficient to move a block. So it's not yet moving. It's not yet in motion. So your what? Acceleration is what? 0. So net force is what? Ma. M is equals to F minus Fr. What's A? 0. M times 0 is equals to F minus Fr. M times 0 is what? 0. F minus Fr. So F is equals to what? Fr. Do you get it now? Or I can, yes, F is, I brought this Fr. Yes, let me just, yes, in case you don't understand. 0 is equals to what? What's your F? That's what? 20 Newton. That's 20 Newton. They've given us in the question. So this is our F. F is 20 Newton. Yes. So F 20 minus. What's the formula for your frictional force? Mu R. So yes, 0 is equals to 20 minus. What's mu? We are looking for mu. Then mu times. What's R? R is what? 40 Newton. I hope you get it now. So you can bring this one. 0 is equals to 20 minus 40 mu. So bring this one here. 40 mu is equals to what? 20. Mu is equals to 20 over 40. So you press it, your coefficient of static friction is what? 0.5. I hope you get it now. Please, if you still do not understand, you can just play back, try to solve it on your own, and make sure you get every question before you move on. Please don't defy confusion. Once you are confused about the question, please just move on. A metal block of mass 5 kilogram. Yes, this is the next question now. Lies on a rough horizontal platform. So just draw it, just sketch it. Mass is what? 5 kilogram. Lies on a rough horizontal platform. Yes. So you have the weight will be what? The weight will be 5 kilogram. This is your weight. Weight is 5 kilogram. Yes. You know that the formula for your weight is what? Mg. So your mass is 5 kilogram times g. That's what? 50 Newton. And you know that for cases like this, R is the same thing as your what? R is the same thing as your W. So your R is what? 50 Newton. W is mg, R is 50 Newton. Yes, so let's go now. They said the coefficient of limiting, they said if a horizontal force of 8 Newton, we will apply a force of what? 8 Newton. Yes, then they said the coefficient of limiting friction between the block is, if the force is going like this, the friction will be like what? Like this. So yes, what's the net force? Net force is what? F minus frictional force, right? What's the net force? The body is just about to move, just slide, so it's just about to move. It hasn't started motion. So you said ma, right? Your acceleration is 0, F minus frictional force. So M times 0 is equals to F minus Fr. Do you understand? Yes. So you have M times 0, that's 0 is equals to F minus Fr. 0 is equals to, I'm sorry for passing through the laborious process. I just want to be sure that everyone is getting it. Yes. So what's your force? F is what? 8 Newton. Yes, this is it. So 8 minus, what's the frictional force? Mu R. 0 is equals to 8 minus, what's mu? That's what you are looking for. They said the coefficient of limiting friction is, yes, what's R? 50. So you have 0 is equals to 8 minus 50 mu. 50 mu is equals to 8. Divide both side by 50. 8 over 50 will give you what? 0.16. So that's the answer for your coefficient of static friction. Yes. So I believe you understand it now. If you don't understand, you can just play back and try to watch it again. Then you'll get it. Let's move on now. So this is the next question. Let me just give you a minute to try it on your own. Just pause the video, see if you can do it on your own. Please make sure you try it on your own before we move on. I'm sure you've gotten it now. Yes, let's just solve it together. Then we'll try to see if your answer is the same with the one we'll be getting here. So yes, like the normal way. Now you know you've been given your force. This is your force. 500 Newton. You know your friction will act in this direction. Then you have an 100 kilogram box. This is your weight. This is your R. Your R is the same thing as your weight. Your R is mg. Weight is mg. R is equals to 100 times 10. R is equals to what? 1000 Newton. Are you getting it now? So you are going to have net force is equals to what? F minus what? Frictional force. So what's your net force? It's 0. Do you understand? How do you know that it is 0? They said it's with uniform velocity. This is it. They said with a uniform velocity. What's the meaning of uniform velocity? That means the acceleration is what? 0. When the velocity is uniform, acceleration is 0. So net force M is equals to F minus frictional force. M times 0, F minus frictional force. So this is 0, F minus frictional force. So what's your F? Your F now is 500. 0 is equals to 500 minus frictional force is mu R. 0 is equals to 500 minus mu times, what's your R? 1000. So you have 0 is equals to 500 minus 1000 mu. 1000 mu is equals to 500. So you divide both sides by 1000 and that will give you your mu. Mu is equals to what? 0.5. I hope you get it now. Yes, let's check another question now. Now, yes, let's go. This is the next question. Yes, just use a minute to try it out. What's the coefficient of static friction between a mass of 2 kilograms? Yes, in this question, they've given you your what? Frictional force. So this is your frictional force, 10 Newton. Then they said, what's the coefficient of static friction? You are looking for what? Your mu, right? Between a load of mass 2 kilograms. So this is your weight. Weight is equals to 2 times 10 mg. That's what? 20 Newton. So your R is also equals to what? Yes, mg. So R is the same thing as weight. R is what? 20 Newton. So they said, what's this coefficient of static friction? Yes, in this case, you don't need to trouble yourself. Just use the formula for your FR state. FR is equals to what? Mu R. So yes, this is the next question. A block weighing 15 Newton rests on a flat surface and a horizontal force of 3 Newton is exerted on it. Yes, this question is actually very technical. Yes, most of you would have. Yes, let's just write it down. They said the block is weighing 5 Newton. So the weight of the block is what? 15 Newton, I mean. So your R is also what? 15 Newton. R is the same thing as W. But you actually don't need it. You see it now. Yes, they said an horizontal force of 3 Newton. This is the force, 3 Newton. Then they said what will be your frictional force? It's actually very simple. What's the formula? Net force is equals to what? F minus what? Frictional force. So what's the net force? You know it's 0, right? Because it's not moving. What's your frictional force? 3 minus Fr. So Fr is what? 3 Newton. You may be surprised. Oh, why don't you use 15 Newton? It's not there to confuse you. You only need your 15 Newton if you don't have your Fr before. Like let's say you don't have your Fr, you need to get your Fr. You can now say mu R. Yes, this is, but now you've been given Fr, so you actually don't need your R again. So Fr, frictional force is what? 3 Newton. Please be careful of this type of questions. Yes, let's go. Yes. Now, yes, let me just say this in addition to that. before we move on. So I said frictional force is what this is the we should have used we may be bothered that why don't we use R? Yes, we are looking for our frictional force. We should have used this formula mu R. Yes, but our R is 15. We don't know our mu. We don't know our mu. So this formula cannot work. That's why our R is useless, because we don't know our mu. So you just go by the normal method. Net force is equals to what? F minus frictional force. Net force is 0. Your force is 3. Then minus frictional force. Frictional force is 3 Newton. Yes, let's move on now. Now, before we take the next one, let me just let's go to the next step. Now, when they say the body is sliding or the body is now moving, yes, the only thing that you need to ask is that your net force is always F minus what? Minus frictional force. So in this case, it will no longer be, it will be MA. So you just put your acceleration here. It will no longer be 0 when the body is moving. So you just put your acceleration here. You can be asked to find it. Don't worry, we'll take questions on that now. So there's just that. Then you can be asked to find the speed. This is the formula you use. Mu is equals to u square over 2gs. Please take this formula very importantly. Mu is equals to u square over 2gs. Mu is equals to u square over 2gs. Yes, so that's all. Let's take another question now. So yes, this next question now. A force 10 Newton. Let's yes. Drags. Can you see drags? So the body is now moving now. This is the mass 10 kilogram. So what will be your weight? Weight is what? 10 times. Weight is mg. So 10 times 10. That's what? I'm sorry. Yes. So weight is what? 10 times 10. That's what? 100 Newton. Yes. So let's move on now. So they said a force 10 Newton drags a mass. So this is the force. Is dragging the mass. Yes. Let's say they said if the acceleration due to gravity is, you know that already. Okay, with an acceleration of 0.2 meter per second square. So the acceleration is what? 0.2 meter per second square. 0.2 meter per second square. Then they said if the acceleration due to gravity is 10 meter per second square, the coefficient of friction is what? Yes, we've already used our G. This is it. G is 10. Yes, they said what's the coefficient of friction? So write your formula. Net force is what? Your friction will be here. Your frictional force will be here. So net force is equals to F minus frictional force. What's your net force? MA is equals to what's F? F is what? Our F is 100. No, let's check the question. Yes, this is it. A force of 10 Newton. So our F is 10 Newton. So F10 minus what's frictional force? Frictional force is what? Mu R. What's mu? Mu times. What's R? You know that our R is the same thing as what? Our weight. Our R is mg. So that's what? 100. So we have our mass. What's our mass? Our mass is 10 kilogram. Times what's our acceleration? 0.2 is equals to 10 minus 100 mu. So 10 times 0.2, that's what? 2 is equals to 10 minus 100 mu. So collect the like times. 100 mu is equals to 10 minus 2. 100 mu is equals to 8. Mu is equals to 8 over 100. Mu is equals to 0.08. So the only difference is that your A will no longer be 0. So the value of your A that you're given, just slot it in. So that will get you your answer. Yes. Let's take another question now. So this is the next question. When a box of mass, all these questions are actually jam-packed questions. So immediately after you finish watching this video, just go to your remix or your past questions. Try to solve every form of question there. Yes, when a box of mass 45 kilogram is given an initial speed. So they've given you the speed, initial speed. That's what U. U is 5 meters. There's actually a difference between U and mu. Do you understand? This mu is the coefficient of static friction. This U is the what? Is the initial speed. Yes, let's move on. Of 5 meters per second, it lies along a horizontal floor, a distance of what? 3 meters. So the distance is what? 3 meters. I gave you a formula relating this. What's the coefficient of kinetic friction? Coefficient. So I told you that to get this, when you are to get the speed, you use what? Mu is equals to u square over 2gs, right? So what's your mu? Mu is equals to, what is your u square? 5 square over 2 times 10 times 3. 5 square is what? 25 over 2 times 10, 20 times 3. This is what? 25 over 20 times 3 is what? 60. This is what? 5 in 25, 5. 5 in 60, 12. So mu is what? 5 over 12. Do you get it now? Yes. So that's just that. Let's go to the next case now. Now, if you remember at the beginning of this video, I said something that there's a common formula that is used. Mu is equals to what? Tan theta, right? Yes, and I said this is only effective if the body is what? Sliding. The body is sliding. If the body is in motion. If the body is in motion. Yes, so this formula is very vital. Let's just review all the formulas together now. We said friction is what? Mu r. That's the first formula. Then we said net force is what? Net force is F minus what? Frictional force. Then we said R is always W. Do you remember that? Now, this for the normal ones. Then when we get to a body that is moving, when the body starts sliding, we said MA is equals to what? F minus FR. Then we also said mu is equals to U square over 2 GS. Then we said mu is what? Tan theta. So I think we've not done anything more than this. So let's just take one last question before we move on. Yeah, so this is the question now. A body of mass 10 kilogram rests on a rough inclined plane whose angle of tilt theta is variable. Theta is gradually increased until the body starts to slide and the plane at 30 degrees. Yes, this is actually what they are saying. There's an inclined plane, but you don't need to stress yourself. They're giving you the theta and you know it's sliding. Yes, the coefficient of limiting friction. So that's what we use it for inclined plane. We use this formula for inclined plane. Mu is equals to what? Tan theta. So we will launch into inclined plane fully shortly. So mu is what? Tan. What's your theta? That's what 30. So mu is what? Tan 30 is what? 1 over root 3. Or if you press it in the calculator to give you what? 0.5771 or 0.58. Yes, so that's just that. That's just that. Let's go into inclined planes now. But before then, let's take a special case. Yes, let me explain that now. Pause it.